Okay, the study guide for test 3, unit 5. So our first problem, we are evaluating problems 1 through 3 using our graph. So we have these f functions and this g function. Now looking at the picture itself, it's a little hard to see, but down here is our f function representing this parabola. So the parabola is going to be referring to our f function, and therefore our g function will be the straight line, as we can see indicated here. G is our straight line. All right, so now that we've identified which is which, we can go ahead and try to answer this problem. Now, as a reminder, we learned in class that if you have f of x, okay, what's inside the parentheses is your x value, hence the x there, and what the whole thing is equal to, the whole thing, means y, our y value. So when we look at problem 1 and it says f of 2, that means the x value is 2, and it wants to know what's the y value when x is 2 on the parabola. So I go where x is 2, all right, so here's where x is 2, and then I look down and I see that's this point right here. Here's where x is 2, this is its y value. So I have negative 2 plus, now I'm going to do the same thing, but now I'm going to look to the g. When x is 2, what's the y value on the g? So now I look up. This is where x is 2. Its y value is 2. So I have negative 2 plus 2, which is 0. All right, so now moving to our next one. We're going to evaluate when x is negative 6, what is its y value? So I go to negative 6, and I look to the parabola. I look all the way up. This is that point where x is negative 6, and its y value is 14. We have a subtraction sign. We're going to do the same thing for g. So we go to where x is negative 6, and then we look up to the g. So this is where x is negative 6. Its y value is 10. So we have 14 minus 10, which is 4. Okay, we're going to do the same thing, but for number 3, we say f is negative 2. What is its y value? So I go where negative 2 is. I go to the f, that's the parabola, that's this point right here. I see that x is negative 2, and its y value is also negative 2. Then we have our times sign. Doing the same thing for g, we're at negative 2 for the x, but we're going to go to the g function. That's the one with the straight line. That's this point right here, where x is negative 2, and its y is 6. So negative 2 times 6 is negative 12. All right, going to do a few more. It says evaluate g of 0 divided by f of 0. So once again, right here, this is our f function. Our f function is the parabola, and our g function is the straight line. So g of 0, so I'm going to go to 0. So here, oops, give me a color. Here we go. This is where x is 0, and we want to know the y value for g when x is 0. So I look up, here's that point, x is 0, and the y value is 4. So I have 4 over, now I'm going to do the bottom, when x is 0, what's the y value for f? So I can see that the point on the parabola is right here when x is 0. The y value is negative 4. So 4 divided by negative 4 is negative 1. All right, so now we're going to be doing the composite functions on a graph. So we are starting where x is 4. So I go where x is 4. I'm going to the g function first. So that's the straight line. So here is where x is 4 on the g function, and I get a 0. Now I'm going to take that 0, and I'm going to go ahead and plug it into the f. So now I go to where the 0 is on the x-axis, All right, and then I'm going to the f function. That's right here. So when x is 0, the y value is a -4. All right, our next one is another composite. So we'll be jumping between the functions. So our x is -2. We're going to start off with the f function. So here is -2. I go to the f function. That's this point right here. This is where x is -2, and I get a -2. Now that I have a -2, I'm going to plug it into the g function. So I go to the g function where x is -2, and I get a 6. All right, so we're going to continue doing that evaluating, but instead of seeing it on a graph, we're going to see it within a table. So we have g of 3. Once again, when x is 3, it wants to know what is the y value. So I go where x is 3, that's our top row. X is 3. We want to go down to the g, and we get a 3. We have our minus sign. Now we're going to do the same thing. Now we're going to do this one. The x is 1. We want to know what the y value is for y. So if x is 1, we get a 4. And so 3 take away 4 is -1. All right. Our next problem 8. We have f of 5. So when x is 5, we're going to go to the f. So x is 5. Our f value is going to be -8. Then we got our plus sign. And now we have h of 2. So we go where x is 2. And this time we're going to h. So we care about this number here. We get a 2. So -8 plus 2 is -6. Okay, and so now we have number 9. We're going to evaluate. We got f of 2. So x is 2. And we want to go to the f function. So that's going to be 6. Then we have our time sign. Then we have g of 4, so we go where x is 4, and we're going to go to the g function. So the y value is 7. And so 6 times 7, 42. All right, continuing, just doing some different type of operations. H of 3, so we go where x is 3. We're going to go to the h function. That's going to be a 9, so on top of the fraction, we have a 9. F of 2, that means x is 2, but we're going to the f function, so we're getting a 6. We have 9 over 6. That can be reduced by 3. So we'll have 3 over 2. So 3 over 2 is our answer. Okay, number 11, we have a composite function. So we are starting where x is 1. We're going to go to f first. So here we're going to get a 4. So now that we have a 4, we're going to plug it in to g. So I go back to the x row. I go to 4, and now I go down to where the g is. G is this number right here. It's going to give us 7. So the answer is 7. All right, so we have x as being 2. We take the x, we plug it into the g. So we go to 2 for the x. We go down to g, that's 3. Now we're going to take this 3 and we're going to go to f. So we go back to the x row, we go to 3, and now we're going to go to h, which is a 9. All right, so now we're going to evaluate with an equation. So it says evaluate g of -1 minus g of 3. So our g is this polynomial right here. And what it's asking us to do is to replace all the x's with a -1. So I'm going to do that. I have 7 times -1 squared plus 5 times -1 minus 2. All right. And then we have subtraction. Then we're also using the g function again, but we're going to plug in a 3 this time into the x. So we're going to have 7 times 3 squared plus 5 times 3 minus 2. And now we're going to do the math. So we're going to do what's inside our parentheses first. So inside my parentheses, I have negative 1 squared, which makes positive 1. And positive 1 times 7 is 7. 5 times negative 1 is negative 5. And I have my minus 2. So 7 take away 5 is negative 2. So I have negative 2 minus 2. And that's going to give me negative... Oh, my apologies. I made a mistake. Oops. Come on, eraser. All right. 7 take away 5 is positive 2, and then we bring down our minus 2, so 2 minus 2 is 0. All right, I'm going to bring down my subtraction. Now to do the other one, 3 squared is 9. 9 times 7 is 63. 5 times 3 is 15, and then we have our minus 2. So 63 plus 15 is 78 minus 2. That's going to give us 76. And so now we have 0 minus 76, which gives us negative 76 as our answer. Question 14 says, write the function g of x minus f of x, simplify if necessary, if needed. So we're taking the g function here, and we're going to be taking the f function, and we're going to subtract them. So we have the g function going first, being 7x squared plus 5x minus 2. Then we are subtracting, and then we're subtracting the f function. The f function is 2x squared minus 3x minus 2. All right, so since we don't have any numbers where x is just x, they basically just want us to write a new polynomial. So we have a minus sign because we're doing g of x minus f of x. So all of these terms inside the green must get the minus sign. So a negative times a positive is a negative, so it gets negative 2x squared. A negative times a negative is a positive, so positive 3x. And a negative times a negative is a positive, so we get positive 2. So now we can go ahead and we look at the problem. We find any like terms and we want to combine them. So we've got 7x squared minus 2x squared. That's going to give us 5x squared. We have 5x plus 3x. That is 8x. And then we've got negative 2 plus 2. That would make 0. And so now we have written the new function. All right, so we are going to be multiplying two functions together and simplifying if necessary. Our h function is 2x plus 7, and our f function is 2x squared minus 3x minus 2. It's asking us to multiply, so I'm going to use the box method to do that. You can use any method you like. My first polynomial has two terms, so I'm going to need to make a box that has two rows. Draw a line down the middle, one row for the 2x, one row for the 7. Then my next polynomial has 1, 2, 3, 3 terms. It's a trinomial, so I'm going to go ahead and draw my lines. So you have 2x squared for the first one, negative 3x for the second, and negative 2 for the third. Now I'm going to multiply. 2x times 2x squared is 4x to the third. 2x times negative 3x is negative 6x squared. 2x times negative 2 is negative 4x. Now I'm going to do the bottom row. 7 times 2x squared is 14x squared. 7 times negative 3x is negative 21x. 7 times negative 2 is negative 14. Then we go ahead and we'll notice that we have some like terms here and here. So our final answer will be 4x to the third. 14 take away 6 would be 8x squared. Negative 21x minus 4 more is negative 25x minus 14. And we have our final answer. All right, 16 is saying evaluate. We have ourselves a composite function where they are giving us the value to plug in. So we have our x being negative 2. It is first going to go into the f function. So I am looking at the f of x function first. And all the x's are going to get replaced with a negative 2. So I'll have 2 times negative 2 squared minus 3 times negative 2 minus 2. So doing the math, negative 2 squared is 4. 4 times 2 is 8. Negative 3 times negative 2 is positive 6. And we have the minus 2. So 8 plus 6 minus 2 is going to give us 12. And now that we know we have 12 here, we're then going to substitute it into h. So we have h, which is 2x plus 7. And we're going to take this 12 and we're going to plug it right into its x. So we have 2 times 12 plus 7. So that's 24 plus 7 gives us 31 as our answer. Number 17 is also asking us to evaluate a composite function, but this time they did not give us the value for x. So what we're really creating is a new equation, a new function, a new polynomial. So we're starting off with, once again, we're going backwards. So we're doing g first and then h. So I always like to set up like this. I can write g first, 7x squared plus 5x minus 2. And then I have h after that. And since g is going into h, I'm going to take this entire g equation and I'm going to plug it into the h equation. So wherever I see an x, I will replace it with 7x squared plus 5x minus 2. So my equation would look like 2 parentheses, then a plus 7. And inside those parentheses, I'm going to now have, instead of writing x, 7x squared plus 5x minus 2. Now I'm just going to clean up the equation. I'm going to distribute the 2 because it's in front of parentheses. So I'm going to end up with 14x squared. 2 times 5x is 10x. 2 times negative 2 is negative 4. And then I have my plus 7. I'm going to combine like terms. Negative 4 plus 7 is positive 3. And that is our new function, f of g of x. So it says simplify the following. So we have 5x minus 2 squared minus 6 times x plus 3. So since I have a square, what that really means is that I have x minus 5 times x minus 5 subtract 6 times x plus 3. Which means since I have two binomials being multiplied together, because squared means that there's two of them, and what's happening is multiplication because two parentheses are next to each other, I'm going to go ahead and use the box method. I need 2 rows, 2 columns, because the first one has 2 terms. So 1 row for the 5x, 1 row for the negative 2. I need 2 columns, 1 for the 5x and 1 for the negative 2. I'm going to multiply them together. So 5x times 5x is 25x squared. Then 5x times negative 2 is negative 10x. Next row, negative 2 times 5x is negative 10x, and negative 2 times negative 2 is positive 4. I do have like terms on those negative 10x's. So we have 25x squared, negative 10 minus 10 more would be negative 20x plus 4. Now I do have a negative 6 here that needs to be distributed to the x plus 3. So -6 times x is -6x. -6 times 3 is -18. And now I want to combine any like terms I may have. So I have a like term here, a like term here and here, and like terms here and here. So final answer would be 25x squared minus 26x minus 14. And now we've gone ahead and simplified it the best we can. All right, we're going to simplify the following just like we did for part A. We're doing the same thing in part B. You'll notice when we're looking at this problem, over here we have x minus 5 squared, which means there are 2 of those x minus 5s. We also have x plus 3 and x minus 3 getting times together. So there's 2 spots where I'm going to need to use the box. Once again, you can use any method for multiplying your polynomials that you like. I prefer the box. So here we've got x plus 3, so that will go here. 1 row for the x, 1 row for the 3. X minus 3, 1 column for the x, 1 for the -3. I'll do the same thing over here. I have x, -5, x, and -5. Now I'm going to go ahead and multiply everything inside the boxes. X times x is x squared. X times -3 is -3x. 3 times x is 3x. 3 times -3 is -9. So once again, we do have like terms here. So we have x squared, 3x, take away 3x is 0, so we won't have anything, minus 9. Don't forget that there is a plus sign here. We are adding these two together when we're done. We do the same thing for the other box when we multiply the x minus 5 times the x minus 5. X times x is x squared. X times -5 is -5x. -5 times x is -5x. -5 times -5 is 25. We do have like terms here. So we'll have x squared, -5 minus 5 more is -10. So we have -10x plus 25. And now we just want to combine like terms. Here I have 1x squared, 1x squared. That makes 2x squared. There's no other x values, x terms. So we're going to have -10x. And then we have 25 minus 9, which is 16. So these two are going to go together to give us 16. And we've got our answer. All right, so for this one, it says, given the polynomial, list the possible rational roots. So this is the P over Q type problem, where the P is the constant term and the Q is the leading coefficient. So we are going to find the factors of P and the factors of Q, and then we're going to divide them. So factors are the numbers that multiply to create the value you're looking for. So in this case, we're trying to find the two numbers that multiply to give us 2. 1 times 2 gives us 2. -1 times -2 also would multiply to get us 2. So we have to account for that idea. So we're going to put plus and minus signs in front of each of our factors. There's nothing else that multiplies to give us a 2, so we're done with the top. For the bottom, numbers that multiply to give us 6. Well, plus and minus, 1 times 6 would do it. 2 times 3, so we'd have plus and minus 2, plus and minus 3. So now we want to make our list. So 1 divided by 1 is 1. Don't forget your plus and minus sign. Then we're going to do 1 divided by 2, which makes 1/2. 1 divided by 3 is 1/3. And then 1 divided by 6 is 1/6. 1 can't get divided by anything else. There's no more numbers in the denominator. So now I can go ahead and move on to doing the 2. All right, so now I'm going to go 2 divided by 1, which is just 2. Then 2 divided by 2 is 1, so I don't need to write it again, and do not write it again. Then you have 2 divided by 3, so you have 2/3. And then you have 2 divided by 6. Well, 2 over 6 is really 1/3 if you reduce the fraction. We've already got 1/3 right there. We do not need to write it again. And now we've made the list of our possible rational roots. Okay, let's look at number 20. Same idea. The p is the constant term. The q is the leading coefficient. So we are doing the factors of p over the factors of q. All right, so our p numbers that multiply to give us 10, 1 times 10, and 2 times 5. For the denominator, two numbers that multiply to give us 2 is 1 times 2, and there's nothing else. So now we're going to go ahead and make our list. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. There's nothing else in the denominator for me to take 1 and divide it by, so I'm going to go ahead and move on to 2. 2 divided by 1 is 2. 2 divided by 2 is 1. We've already got it. We do not need to write it again. And there's nothing else for me to divide by, so I'm going to move on to 5. 5 divided by 1 is 5. 5 divided by 2 is 5 over 2. And then our last one, we got 10 divided by 1 is 10. 10 divided by 2 is 5. We've already got it, so we have our list of possible rational roots. Okay, it says given this polynomial, determine if x minus 9 is a factor. Okay, so there's a bunch of different ways you could do this. You could divide the polynomial by x minus 9 and see if you get a remainder of 0. If you do, you know it's a factor. You could use your synthetic division and divide the polynomial by positive 9, and if you get a remainder of 0, you could then determine if it's a factor. Or you can go ahead and find out what the potential x-intercept would be of x minus 9, substitute it in, and see if this is going to be a factor or not by whether or not you get a 0 when you plug it in. So if I were to assume that x minus 9 is a factor of this, I would ask myself the question, what number minus 9 is equal to 0? Positive 9. This is a possible x-intercept. And if we figure out if this is an x-intercept or not, then we figured out if it's a factor. Because if this is a factor of this polynomial, then it would provide an x-intercept. So x-intercepts as a point is an xy. So the x is 9, but the y for an x-intercept is always 0. So if we take the 9 and we plug it into the x's and we get the number 0, then we've proven that 9 is an x-intercept. Therefore, x minus 9 would be a factor of the polynomial. So let's look at the algebra. So if I have negative 5 parentheses 9 to the 4th power plus 55 9 to the 3rd power minus 81 9 to the 2nd power minus 75 9 minus 54. So I'm going to go to my calculator. I'm going to type in negative 5 parentheses 9 with an exponent of 4. That gives me negative 32805. All right. Now I'm going to do 55 parentheses 9 to the third power. That gets me 40095. Now I'm going to do negative 81 parentheses 9 squared, and I get negative 6561. Now negative 75 times 9 is negative 675 by minus 54. Now I'm just going to type this into the calculator. Negative 32805 plus 40095. Subtraction 6561. Subtraction 675. Subtraction 54. I get the number 0 when I do that. That confirms that 9 is an x-intercept. And since it is an x-intercept, that makes x minus 9 a factor of the polynomial. If you got a number that wasn't 0, then you would say, no, it's not a factor of the polynomial. Okay, this says given 2x to the third minus 6x squared minus 31x, determine if x minus 3 is a factor. So in the previous problem, we used the method of figuring out what the potential x-intercept would be and plugging it in to see if we get a 0. This time, I'm going to use a different method that will do the same thing. Now, in class, you have learned many different methods to figure this out, so that's why I want to show you a variety. So you can choose which one that you like to do. So this time, I'm going to use synthetic division to help me determine if this is a factor. So I'm still going to ask myself the question, what number minus 3 would equal 0? That would be positive 3. So I'm going to use positive 3 and divide my polynomial by 3 by using synthetic division. So I'm going to put a 3 on the outside. Now inside this big L, I'm going to put all the leading coefficients. I'm going to put all the coefficients in there. So I'll have 2, negative 6, include your signs, negative 31, and positive 15. And the idea is, if I get a remainder of 0, then I know this is going to be a factor of the polynomial. If I don't, then it is not a factor of the polynomial. So first thing I'm going to do, I'm going to drop the 2 down like so. Now I'm going to go 3 times 2. That gets me 6. And I'm going to write it inside the L. Negative 6 plus 6, that gets me 0. Well, now I'm going to do it again. 3 times 0 gets me 0. Now, negative 31 plus 0 is negative 31. Then I'm going to do positive 3 times negative 31 is negative 93. Well, 15 minus 93 is negative 78. So now I've run out of numbers in my L, so I stop. Now when we do synthetic division, when we divide, if our problem started with the degree of x to the third, it goes down by 1. So this is x squared plus 0x minus 31. So x squared, x, no x. And so the last number is our remainder. Well, our remainder wasn't 0. Since it isn't 0, that means that x minus 3 is not a factor of the polynomial. If you did get a 0 there for the remainder, then it would be a factor. Once again, problem 22 and 21 are doing the same thing, just using different methods. Choose whatever one is easiest for you to do. Determine the remainder when the polynomial d of x is divided by x minus 5. Okay, so it's just asking us to do division, so you can kind of choose what method you prefer to use in dividing this. I personally love synthetic division. I think it's really easy. It's the one I prefer to use. There will be a problem, I believe it's problem 24, where I will review long division. But I'm going to go ahead and do synthetic division. So I asked myself, what number minus 5 would equal 0? Positive 5. So I'm going to go ahead and do synthetic division with positive 5. So as always, you're going to take your coefficients from your polynomial and you're going to put them in there. So I have 8, negative 33, negative 25, and negative 50. So we're taking all of our numbers. We're just removing the x's. All right, and once we have it set up, we're going to go ahead and bring the 8 down. And so we're going to start by going 5 times 8 is 40. We have negative 33 plus a 40, that's 7. Then we're going to go 5 times 7, that's 35. Negative 25 plus 35 is positive 10. And then 5 times 10 is 50. Negative 50 plus 50 is 0. So it asks us to determine the remainder. So to help us figure out which number here will be our remainder, it works like this. Our highest degree here is x to the third. When you do a synthetic division, it reduces the exponent by 1. So this is starting off as x to the second plus x plus no x with a remainder of 0. So we found our answer. We have found the remainder is the number 0. All right, we are doing a division problem. Now, since we are taking this polynomial here and dividing it by a trinomial, you must use long division. Synthetic division only works like the previous problem where you have, say, x plus 5 or a 2x plus 3. If you're dividing by a linear with 2 terms, that's not happening here, which means we have to use the long division method. All right, so I'm going to set up my long division. We have our x squared plus x minus 2, our x to the fourth minus 3x to the third plus x squared plus 4x minus 5. So our problem is set up. And what we want to do, we want to figure out what times x squared is going to give us x to the fourth. So x squared times x squared will equal x to the fourth. Now notice how I lined up the degrees here, x squared. We want that to line up perfectly. That's going to help us stay organized. So what I'm doing is saying x squared times x squared gives me x to the fourth. But since I have 2 other terms out there, I got to times that x squared to each one of them. So x squared times x gives me 1x to the third. Then x squared times negative 2 gives me negative 2x squared. Okay, there was nothing else for me to multiply on the outside by. I did all 3 terms. So now I move on to our next step. We're going to draw a line underneath the terms we just wrote. Then we are going to switch the signs for all the terms that we just wrote. And now we're going to go ahead and start doing some of our combining. So x to the fourth minus x to the fourth would be 0. So we're just going to cross it out. Negative 3x to the third minus 1x to the third is negative 4x to the third. 1x squared plus 2x squared is 3x squared. There's nothing left for me to combine, so I'm going to take the next term that I see and I'm going to drop it down. You can only drop down 1 term at a time. And now I'm going to do this process again. All right. So I'm asking what times x squared would get me negative 4x to the third. Negative 4x. So negative 4x times x squared is going to get me negative 4x to the third. Then I'm going to do negative 4x times x is negative 4x squared. Then I'm going to do 4x times negative 2, which is going to give me positive 8x. Once again, I've run out of numbers to multiply by, so I know I've done all that I can there. So now I'm going to do exactly what I did last time. I'm going to draw a line underneath the terms I just wrote. I'm going to switch all the signs. And then we're going to combine our like terms. So negative 4x to the third plus 4x to the third is 0, so I'm just going to cross it out. 3x squared plus 4x squared is 7x squared. 4x minus 8x is negative 4x. Then I take the next term and I drop it down. Now I'm going to go through this process one more time. All right, I'm going to ask myself the question, what times x squared gets me 7x squared? 7 does. So 7 times x squared gives me 7x squared. 7 times x gives me 7x. 7 times negative 2 gives me negative 14. I've run out of numbers to multiply by. All right, so now I'm going to draw the line, switch all of the signs. Now I'm going to combine like terms. 7x squared minus 7x squared makes 0, so I'm just going to cross it out. Negative 7x minus, negative 4x minus 7x is negative 11x. Negative 5 plus 14 is positive 9. I've run out of numbers to drop down, so I have a remainder that is plus negative 11x plus 9 over x squared plus 7x minus 2. And so now I have my answer. Oh, I don't know. Well, let me rewrite that. That's x squared. This was negative 4x, and this was positive 7. So highlighter. I don't know. Technical difficulties. Highlighter. There we go. Okay. So this right here is our answer, and I saw a part just got accidentally erased. This should be a plus sign. And so that would be our final answer.